Okay, our nines times tables. We all learned these in 3rd grade, maybe 4th for some of you, maybe 2nd for some of you. But you knew the answer in 1st grade. You just had to have somebody show it to you. Now we know that 9 times 8 is 72. And 9 times 5 is 45. Also know that 9 times 4 is 36. To the teachers out there, you'll notice I did not line them up in the correct manner. I didn't put my ones in my ones column. I didn't put, I offset it the other way because for all of you, there is a relationship here between the 8 and the 7, the 5 and the 4, and the 4 and the 3, and you all can tell that we have simply subtracted 1. The other relationship, we know that 7 and 2 is 9, 4 plus 5 is 9, and 3 plus 6 is 9. Algebra tells us that whenever we divide by x minus 1 into whatever polynomial we have, we always get a remainder of the sum of the coefficients. For your younger ones, you'll understand coefficients later. But for now, I have an easy method to do my 9s times tables. If I'm doing 9 times 6, all I do is subtract 1. 9 take away 5 is 4, and I'm done. I did 2 steps, but both of them originated from 1st grade arithmetic. I had to know what adds up to 9, and I had to be able to subtract 1 from anything. Well, yeah, but we already know our 9s times tables, Mr. Gilbert. That's not very useful. Well, it also works with the 99s. If I was to try to take 99 times 12, 1 less than 12, 11. 99 take away 11, 88. Throw a comma at it, and we're done. You didn't show your work. Yeah, I did. There was no work. This is easy to do, fun to do, and if you are 8 and you have a 15-year-old sibling that hasn't seen it yet, you'll blow them away. What if we wanted 999 times 563? Well, we're going to be at 562. And 9 take away 5 for 4, 3 and 6, 7 and 2. And we've shown all of our work. And we've done a 3-digit multiplication in our heads. If you really want to show off, you do it in your head and really make them wondering where you're getting this stuff from. That's what makes it fun. And it makes it easy, and it's simple to do. And if I can learn to do it, I'm pretty sure the rest of you can too. Hello again. I'd like to talk to you about your 11s times tables. Now, I know that these are the first ones you learned at the end of 2nd grade because anybody can write down the same number twice. 11 times 9 is 99. 11 times 3 is 33. But of course, we're going to be wanting to do bigger math problems than that. I'd like to know what 11 times 34 is. And I know that most of you are scratching your heads and wondering the same thing. Why would you want to know? Well, sometimes you need to know these things. So the example is 34. And how could we do that with 1st grade arithmetic? Well, we can copy a 3 and we can copy a 4. What goes in the middle? The sum. Now, if I asked you to do that with 51, but don't write anything down, the trick is to remember the 5, remember the 1, and know that 5 plus 1 is 6. And we're good to go. Now, this works for any 2-digit number where the digits add up to 9 or less. If it carries, is that going to be a problem? Well, I'm still going to want to write the 8 down. 1 times 8 is 8. 8 plus 8 is 16. Yeah, there's that carry. I've got to write the 6 down I put the 1 up there, and I've got a 9, and I'm done. Now, how do I check my work? Well, it's simple. Add those together, I get a 7, boom, ties to the center. Same over here, it ties to the center. But over here, 9 and 8 are 17. Take away the 6. Oh, look at that, we get an 11. So how do I know that 2101 is a multiple of 11? Because 1 plus 1 is 2, 0 plus 2 is 2. As long as the sum of every other digit is the same as the sum of all the digits you skipped, it's a multiple of 11. If the difference is something other than 0, it's a multiple of 11 if it's an 11 or a 22 or a 33 or a 44. And if you're doing bigger numbers than that, well, you're a bigger man than I am. But that's 11s in a nutshell. Earlier, I demonstrated 5s and the power of 5s and how fast we could calculate it with a shortcut. So let's do something similar with the power of 11. We know that 11 to the first, and our shortcut tells us that we can do that. Well, our shortcut continues. 1 plus 2 is 3. 1 plus 2 is 3. We get another 1 out front. We're going to do it one more time. We're going to get a 4 this time, and a 6, and a 4, and a 1. We're going to go one more, and we get a 5. Oh, we got a carry, so we're going to put a 1 in here. We're going to get an 11. And we're going to put a 1 in there and get a 6. And we're going to put a 1 out front. We can do it again. And we just did 11 to the 7th in about a minute without writing the same number down 18 times and seeing if our addition was right and all that sort of thing. Where did we have some problems? Well, we had to worry about the carries in here. But other than that, carrying 1, not really a big problem to overcome. At this point, I'd ask if there are any questions. If there are, your mother or dad, they're going to have to answer them for you. Hello again, I'm Gregg Gilbert, and I'd like to talk to you about why the numbers 2 and 5 are vertical mirror images of each other when written correctly. There's actually a reason behind it, I'm hypothesizing. Now, we all know our 5's times tables, and we all know our 2's times tables. But no matter how good you are with your 5's, I'm certain that you're faster with your 2's. So, I'm going to do a quick demonstration of just how fast we can be with our 5's if we use 2's instead. I'd like to know what 5 times 9 is. I'm going to change the 5 to a half. Half of 9 is 4.5. Well, if I took this over there and took that over there, I'd have 9 times 5 is 45. Doing half of 9, 4.5, is different than doing 5 times 9 is 45. And that gets me excited, and I'm hoping it gets you excited as well. Does it work with other numbers? I mean, we all know our 5's times tables. We had to memorize them. I memorized them also. If I know that 72 is 36 times 2, then I get 36 times 10 equals 360. So 72 times 5 is faster as 36 times 10, and I guarantee you it's more accurate as long as you know that half of 72 is 36. And the reason I know you know that is because everybody out there knows that half of 70 is 35, and half of 2 is 1, and everybody out there should know that 35 plus 1 is 36. And if that's too challenging, you can always say this is 60 and 12. So half of 60 would be 30, half of 12 would be 6, and you'd be there. The only thing you have to remember is put a 0 on there, and of course we know 0 is just nothing. So let's just take a quick look at how this works out when we're just doing 5 times 5 times 5 times 5 times 5. We know that we start with 5, and we take half of 5, it would be 2.5. Half of 25, well, we get a 1 out here, and half of the 5 is another 25. Half of 12 is 6, and we get another 25. Half of 62, 31, and another 25. Half of 31, well, we get 15, carry the 1, get a 6. Half of 5 is 25. And of course, half of 156 is 78, and we get another 125, and down here, 3, 9, 0, 6, 2, 5. Now, it took me maybe 2 minutes to show you 5 to the 8th power. If you did that by saying, well, 5 times 5 is 25, and 25 times 25 is 625, and 625 squared is a big number, it would take you a little bit longer. Could we do that with any number out there? If you want to practice at home, you can do 5 times 2,468 in your head instantaneously, because you all know that half of 2468 is 1, 2, 3, 4, with a 0 on the end of it gives you 12,340. And yes, it is that fast, and it is that easy.